Same way, we come back here and say, contents of P behaves like an integer, therefore, P must behave like what? Address of an integer. Always. Correct. Contents of that is an integer. That must be an address of an integer only. It can't be address of a double. It can't be address of a character. It can't be address of a structure. It can't be address of President of India. It can only be address of an integer. Correct. So, must behave like address of int. Correct. Which is actually, in other words, you can write this as ampersand int. Correct. So, P behaves like ampersand int. So, in fact, you could have written that here in the symbol table saying, P is a symbolic reference. It behaves like ampersand int. Actually, P also behaves like int star. Both are actually same data types. There is no difference between int star and ampersand. Because they are same, no? P behaves like this, P behaves like that. P behaves like a cow. P behaves like cattle. Therefore, cow is cattle, no? Very straightforward, right? So, now this is what I call the star tossing rule. This is called the star tossing rule. So, if you say I've got some data type star is there, we can toss the star. You know how to play caroms, you can do it very easily, you know. Just toss the star so it lines up onto the other side of the data type. It is going to change color and become ampersand. Is that clear? Like for example, I'll just give you a simple example. Suppose you say I've got one int star star. What is int star star? Nobody knows. We have never seen this kind of animal before, right? We don't know what it is. Very simple. You just toss the star to the other side. Take one star and toss it to the other side. When it lands up onto the other side, what is going to become? Ampersand. So, it is actually same as saying ampersand in star. There's no difference between the two. Now you got one more star to toss. Toss that also. So, it is going to behave like ampersand int. All three are same identical data types. So, int double star really means address of an integer is the meaning of int star star. Like int star is an address of an integer because int star and ampersand int are same, fundamentally same data type. There's functionally 100% they're identical. There's absolutely no difference between the two, right? I mean, is that clear? Now, since we know that P behaves like an ampersand int, why don't we write a couple of statements on that? I think we should do that, right? So, the only thing that you can store into the box P equals must be something which must behave like an address of an integer. You can't store anything else. P is an address of an integer means what? Like I is an integer, which is contents of 2000, right? You can, into the I, you can only store an integer. You can't store a double fission number. Or you can't store a donkey into it. You can only store an int. The same kind of animal has got to be stored. So, P is a data box now, which is an address of an integer. All addresses are always 4 bytes. Now, we assume that. So, P is a 4 byte value actually. So, the size of this P is a 4 byte box and the only things that you can store into that 4 byte box are addresses of integers, nothing else. Correct? For example, in this program, we have only one integer and we get only one address of an integer which is 2000. 2000 is not the address because 2000 after all is our number. Really speaking, you should use it by the symbolic reference ampersand I. Ampersand I you can definitely use as part of an executable statement even though you could not use it as part of declarative statement. Is P equals ampersand I is a perfectly valid statement. Correct? This is P is int star which is ampersand int. Ampersand I is ampersand int because I is an integer. Is valid? No problem on that. When you write like this, actually what really happens in the memory map. So if you look at the memory map, let's just try to draw the memory map of the data segment. At 2000, we had a 2 byte box, contents of 2000 and 2001, which went by the symbolic name I, correct? So whenever we said I was contents of this 2000, 2001, correct? That's the meaning of that. Now we got one more box, which is P, which is actually contents of 2002. Now we know that P is an address, so it must be a 4 byte box. These contents of actually 2002, 2003, 2004, 2005. It's a 4 byte box actually. And contents of that goes by the name P. And now we say, I'm going to store a value into this P. P equals, what did we do here? Ampersand I, correct? So that is, value is actually 2000, right? I mean, 2000 is address of, in this particular example, it is 2000. Tomorrow it may be 3000, whatever that is. Wherever you put the I, that address we have gone and stored into this box. So this 4 byte box contains the address 2000 at this point of time. Now let us write just two more statements. I equals 4 semicolon. So what is it going to do? It's going to change the contents of this box to 4. Everybody knows that. So it's what I would call the anonymous access. Because I want to change this contents of 2000. Please use the name I. You can always change it. Anybody who can use the name I can change the value of I. No problem. They have got the access. So now I want to write one more statement. So we say star P equals 5 semicolon, whatever that means. Now that is a valid statement, first of all, because 5 is an integer. Star P we know is a fellow which behaves like integer, so it is alright. Let's just try to figure out the meaning. And what is star P? Star P is actually contents of P which behaves like the integer. What is P itself? I is contents of 2000. So what is P? Is contents of 2002. P is always contents of 2002. Don't forget that. P is the value inside this 4-byte box. So therefore, P is contents of, just like I is contents of 2000, P is contents of 2002. No questions on that, right? So what is star P? Remember, star, unary prefix star is the contents of operator. So star P really means is contents of 2002, correct? Is double contents of. So star P really means contents of 2002. That is what you say. Please change that to 5 semicolon is what is the statement that we have written. Please change contents of P, which is contents of 2002 to be changed to 5. And we know that what is this contents of 2002? What do you have right now? Current value is 2000. No questions on that. Currently it has got a value 2000. Therefore, star P equal to 5 means please change contents of 2000 to 5. We know contents of 2000 is an integer, no? It's changed to 5, no? So what is the value of I now? Without using the name I, this fellow now has managed to change the value of I, correct? You understand? So this is actually what we call the anonymous access. This is anonymous access because you have to use the name to access it. It is Shastry, come here. This Shastry will come here. You want Shastry to do something, you say Shastry, come here. Shastry, do this. See, that is, you are using a name to access a person. That is called anonymous access. Correct? But I want to do, sometimes I want to access a person without using the name. How to do that? Hey, you come here. You go there. See, that is when you say you have to use a finger, right? You have to point at the person and say, you come here, or you come here, you come here, correct? So that means this is the anonymous. See, the advantage of anonymous is very straightforward. It doesn't use a name. They both are accessing the same data box. Both are modifying the contents of 2000, no difference. Now this star P equal to 5 modifies the contents of I equal to 4 modifies the contents of this 2000. Both are modifying. Difference is this is anonymous access because you have to use the name I to modify the contents of that particular box. Here, without using the name I, now P has managed to modify the value of I. Now because it didn't use the name I, that means tomorrow, same star P equal to 5 can modify the contents of J. You can modify the contents of K, X, Y, anything you want. The fellow is capable of modifying, provided you can make it point to that data box. It's called a pointer. P is known as a pointer because P actually contains the address of some inbox. Whichever inbox it contains the address of, we said is actually pointing to this. So whenever you say star P, you are modifying not P. You say you come here, I am not asking the finger to come here. Finger will be there only. Before finger points, I am asking that person to come here, right? So that I can make that finger point to different persons, provided I can generate the addresses of the different persons, right? That is known as a. So P is actually what is known as a pointer to an integer because it always points to an integer box. P contains the address of an inbox. Another nomenclature is P is a pointer to an integer. Now that's the meaning of that. In fact, int star is always read as pointer to an integer. Star is actually in declarative statements. Star means pointer to. Ampersand is address of. So we say int star, we are saying P is a pointer to an integer. Is a pointer to an integer because star P will always be an integer if it is a pointer. If contents of a pointer to an integer is always an integer. Right? The contents of address of something is always the same item. So that's the same. So contents of address of are complementary operators. Now you can see that anonymous access requires the name of the symbolic reference to be used as part of the expression, whereas anonymous access does not require the name of the symbolic reference to be used as part of that syntax. Correct?